Hey everyone, and welcome to the fifth edition of the TestMu conference. I'm Devansh Bhardwaj, a senior product marketing manager here at TestMu, and I'll be your host for this session. Quality engineering has always rested on a quiet assumption, which is you put in the same input and you get the same output, which is basically pass or fail. But agentic systems break that at the foundation level. The same prompt can give you different answers and not necessarily wrong ones. An agent can take a completely different path and still land where you want it. So, what does QA even look like on the other side of that? Not just what you test, but how AI is reshaping the testing landscape itself. Pooja Oza is a senior QA engineer at Walt Disney with 13 plus years of experience in test automation and quality engineering. She's leading a team of QA and SDET engineers. Right now, she's helping that team bring AI into quality engineering from generating tests straight out of requirements to self-healing automation. And she's sharing work that's still in progress, not a tidy retrospective, which I think makes it a lot more useful. A quick ask before we begin. Please feel free to post your takeaways and your learnings on LinkedIn or X, tag us, and use the hashtag TestMuCom so the rest of the community can follow the conversation. And if you have any questions during or after the session, feel free to drop them in the Q&A box and we will address them towards the end of the session. Just a reminder, in case you have to drop off mid session, you don't have to worry about missing out on anything because this, as well as all other TestMu conference sessions, are being recorded and they will be uploaded to our YouTube channel. So I would highly suggest that you all subscribe to our YouTube channel so that you can revisit them at any time and share them with your peers. Enough said. Please join me in welcoming Pooja Oza, who's senior QA engineer with Agentic AI Change, what we test and how we test it. Over to you, Pooja.
Welcome everyone. I'm Pooja. I'm a senior quality engineer at Walt Disney. Today we are going to take a look at how agentic AI changes both the scope of what we test and the methods we use to test it. Now, classic testing relies on a deterministic contract, but agentic systems, they reason, they use tools, they find multiple paths with the same goal. And here is where our engineering strategy has to evolve. Now, to understand it further, think of traditional testing as built like a train or a fixed track. It follows a rigid, predetermined path from point A to point B. If a switch flips or a track shifts by even an inch, the entire run derails and fails. That's our exact match automation. Static scripts checking static DOM elements. Now, agentic system behaves like an autonomous driver. Given the exact same destination, an autonomous vehicle dynamically change routes, stops for pedestrians, or reroutes as per the traffic jams. Now, no two drives look identical, but the goal achieved is safely. Because our software now behaves like an autonomous driver, our quality engineering can no longer rely on fixed track scripts. Today is about shifting from brittle, exact match checks to evaluating dynamic trajectories against strict safety policies and behavioral bounds to build true release confidence. So, here is a core shift. What we test changed before how we tested changed. Traditional testing asks one question: does the output match? Agentic systems break that question because the same goal can be reached through multiple paths. Traditional test automation relies on exact match oracle. Given a specific input, we expect that same output every single time along a single deterministic path. With agentic system, non-determinism means the execution path can vary widely across runs to achieve the same goal. Our core question fundamentally shifts from does the output match to did the agent's behavior stay within the acceptable bounds. Rather than checking for identical step execution, we validate the agent within a bounded behavior envelope defined by three strict gates. Did the agent achieve the user goal? Did it stay within authorization, business, and safety limits? Is every decision and generated answer grounded in verifiable fact? The path may vary from run to run, but the contract stays fixed. Today's roadmap focuses on breaking that exact match assumption, measuring behavior across this envelope, and building real release confidence. When evaluating an agent's path, a single user goal does not map to a single rigid script. In an scenario like moving an appointment, three completely different paths can be possible. Direct execution, asking for clarification, or escalating due to the risk can all be valid. The core test oracle evaluates whether the behavioral contract holds, preserving user intent, adhering to safety policies, and maintaining an explainable execution stress. Now, when testing an agent, the exact path matters far less than the policy boundaries. Take a straightforward example. Move my 3 p.m. appointment to tomorrow morning. Now, depending upon an environment, the agent can take three completely different actions, and every single one is a valid one. If there is exactly one spot open in the morning, the permissions are clear, it moves a 3 p.m. appointment and confirms. Low risk, zero friction. If multiple morning slots are open, 9 a.m. and 11 a.m., acting without asking is a poor experience. The right behavior is pausing to let the user pick. Now, if rescheduling triggers a conflict with a critical meeting or crosses an authorization boundary, guessing is unacceptable. It immediately stops and hands off to a human. In traditional testing, these three traces would look like inconsistent failures. In agentic testing, all three pass because they honor the same contract: intent preserved, policy obeyed, and trace fully explainable. Fluency is not correctness. An answer can look polished, articulate, and completely plausible while failing underlying safety, policy, or grounding constraints. In traditional testing, we relied on a binary pass or fail exact match. With generative and agentic system, quality shifts to a multidimensional spectrum evaluated across five different dimensions. Outcome: did the agent actually resolve the user goal? Is the response strictly grounded in verified authoritative data rather than hallucinated facts? Did the agent follow an allowed legitimate sequence of action and tool calls? Did the execution respect safety policies, authorization limits, and privacy bounds? Was the transaction reliable, performant, and resilient under latency or transient errors? Ask yourself, if an agent produces a wrong but highly polished response, which control in your architecture catches it first? Relying on user bug reports means the failure has already reached production. Evaluating across the entire spectrum through structured pre release testing and real time trace telemetry is the only way to catch subtle high risk failures before our customers do. Let's run a 10-second quiz. A customer asks, "Can I return a discounted item after 60 days?" Look at these two responses. Reply A is direct and confident. Yes, discounted items have a 90-day return window. Reply B qualifies policy boundaries and asks for the context. Final sale is excluded. Other online items, 30 days. Was it a final sale? Hmm. Reply A sounds concise, helpful, completely natural, but it is entirely fabricated. This highlights the core hazard in generative and agentic system. Fluency is not evidence. An answer can be articulate, grammatically flawless, and sounds completely authoritative while being 100% wrong. This is why our quality engineering checks cannot rely on plausible surface level text. Our test oracles must explicitly validate source, grounding, and policy constraints. From contradictory news summaries in early iOS 18.3 builds to hallucinated advice in public search and city chatbots, share a common root cause: missing behavioral controls. When system lacks source fidelity, risk gates, or authoritative grounding, confident outputs turn into major quality regressions. Release confidence requires establishing explicit guardrails and domain specific regression tests that block ungrounded behavior. So that's the shift in what we are testing. Now we will actually test it. This half covers the mechanics, how AI help us build faster coverage, where humans still sign out, and how all of this comes together at the moment we decide to ship. AI fixes the blank page problem in testing. Now, traditionally, an engineer starts with a blank page, writes every test case by hand. It's slow and coverage is limited to what one person can remember. With AI, we don't have to start from scratch. AI instantly suggests execution paths, edge cases, and redress scenarios based on product requirements. Our role as engineer doesn't go away. It moves up a level. AI drafts the test quickly, but engineer verifies the risk, checks the facts, makes sure the assertions are solid before anything ships. AI proposes the coverage, the engineer owns the proof. Self-healing locators solve UI fragility, but blind healing introduces a dangerous risk, the false green. When a UI change breaks a selector, the core question isn't can the tool find another button to click? It's did the actual business action happen? Now, say suppose a checkout page updates its layout. The automated script can't find place order, so it blindly swaps the locator to another clickable element nearby, say save for later. Now the test clicks it, passes green, but no purchase was ever made. The test passed, but the customer checkout failed. Now, in governed healing, the tool proposes the new locator, but it must prove the outcome. It verifies the database state, confirms the order receipt was generated, and records a repair in the trace for engineering review. So, a test run shouldn't turn green just because a selector was fixed. It turns green only when the user outcome is proven. Now, AI gives us incredible speed. It drafts tests for us, clusters failures, spots pattern across traces, but speed is just an input package. It is not release approval. When it comes to real release gates, human judgment is irreplaceable. In this case, human define harm, setting the safety boundaries and risk tolerances. Human own accountability, authorizing high impact and irreversible actions. Human sign off on releases, making the final go no go call. Now look at the four confidence boosters at the bottom: datasets, traces, adversarial testing, and human review. Ask yourself which one would you fund first? Now, the right investment always attacks your team's largest uncertainty. Now, if your problem is repeatability, invest in golden datasets. If it's unknown behavior, invest in trace telemetry. If it's security exposure, invest in adversarial red teaming. Now, if it's irreversible business impact, invest in governed human review. To put everything we have discussed into a concrete context, this slide illustrates an architectural blueprint, a conceptual reference model. It shows how agentic testing principles apply to a complex real world domain like media player. In the video streaming, we have markers like timeline markers, auto skipping recaps, intro cues, dynamic ad insertions, and credit rolls. Now, they frequently break the traditional test automation. Standard scripts simply check if a button is there on the UI and click it. But if a network throttles or a video stalls, the button might vanish. The click might happen without the playhead ever moving. This blueprint demonstrates how agentic testing framework continuously evaluates the stream across the five different phases. Now, first we can take recap marker. As the show starts loading, the agent automatically triggers a skip. The test confirms the video jumps to the exact right second with the clean audio and zero lag. Intro cues. Even if the internet slows down and video quality fluctuates, the skip intro prompt must appear on time. Clicking it must land cleanly at the start of an episode with perfectly synced sounds and no frozen frames. Ad breaks. When an ad plays, the system checks behind the scenes that ad tracking fires correctly. If it also ensures that the player switches between the episode and the ad smoothly without crashing, freezing, or glitching. Credits. When the credit rolls, the video shrinks to a smaller window, picture in picture, while silently preloading the next episode in the background so it starts instantly without buffering. The system constantly reviews the entire playback log. It if everything worked as expected, it marks the test as pass. If anything lagged or skipped off target, it instantly flags the exact timestamp so engineers can fix it. Reports or bundling exact timestamp data for engineering triage. Now, the takeaway of this blueprint is clear. When video playback changes unpredictably, our testing rules make sure the quality never drops. Now, let's connect the trace evidence from our video player blueprint directly to how we make release decisions. In the traditional model, our pipeline runs a test suite, looks for 100% green assertion check, and automatically triggers deployment. It is fast, but it is completely blind to behavioral drifts. In our video playback scenario, a traditional script only checks if the skip intro button was clicked. The test finishes green, but behind the scenes, the stream drop frames, lost audio video sync, or failed to trigger its ad telemetry beacon. The test passed, but the customer experience broke in production. In an agentic architecture, a build is shippable only when behavior is proven across four explicit points. We analyze that the full playback trajectory, verify the presentation timestamps within are landed within a particular time frame, and the codec switch cleanly without a crash. We confirm the agent state strictly within policies, such as never skipping mandatory mid-roll ad pods or exceeding buffer limits. Now we also verify that the telemetry beacons like the start endpoints and complete fired and logged verifiable proof in our observability store. For high impact changes or detected regression, an ISTAT reviews the package trace bundle before authorizing the release. The core philosophy of the shift is simple. We don't ship when the tests are green. We ship when the behavior is bounded. So, what does this all mean for you? The blueprint we just walked through pays off differently depending upon where you sit. And since most of you are quality professionals, I want to walk you through all three. If you are an engineer, you already know this pain. Chasing a broken selector every time the UI shifts, rewriting the same test two or three times a sprint because the click path changed, not the actual behavior. What changes here is simple. The test stop caring how the agent got to the outcome and start checking whether the outcome was held. That's what cuts the rewrite cycle. You get fewer false failure and a lot less time spent on maintaining the brittle scripts that breaks for reasons that have nothing to do with the quality. If you are in QA or SDET role, and I suspect that most of you are, this is the your job changes. It doesn't shrink point. AI proposing test coverage doesn't replace your judgment. It removes the blank page problem. Instead of handwriting every edge case from scratch, your time goes in reviewing, verifying, and owning the evidence trail behind each release. What you get back is defensible record behind every release, not just a green check mark that may or may not mean what everyone assumes it means. And even if you are not in a leadership role yourself, you will eventually need to make this case to someone who is. So here's that version. This isn't really a testing story at that level. It's a why did we ship story. When something goes wrong after a release, leadership needs an answer that's a trace, not a shrug. That's what release decision resting on evidence and human sign off actually buys you. Fewer incidents, faster release cycles, and paper trail if anyone ever asks you why a build went out the door. The cost curve underneath all of this is well understood. Prevention is always cheaper than an incident. I'm not going to put a dollar figure on that today because I don't have a validated number to back one up. And I did rather tell you that honestly than make up one. But you don't have to take my word for the cost of getting this wrong. There are three examples listed in one of the slides. To close things out, think about what happens tomorrow morning when you are looking at your test dashboard. If you take away just one practical habit from today, let it be this: stop trusting the green checkbox itself. Here are three practical questions you can ask your team on very next pull request. If AI test passes, did you actually check the logs? Look at your network calls, the database state, and the timestamp. Don't let a test pass just because an agent gave a polite, well phrased response while quietly failing behind the scenes. Did you set hard guardrails? Make sure your test suits. Verify that the agent never exceeds token budgets, never retries an API call in an infinite loop, and immediately escalates when it hits an unknown state. Use AI to do heavy lifting. Let it generate 20 edge cases and cluster fail logs in seconds, but keep the keys to you. The human engineer is the only one who decides if the risk profile is safe enough to ship to real customers. Remember, we don't ship because the test turned green. We ship because the behavior is bounded and proven. Thank you all so much for your time. Let's open up the floor. What practical testing challenges is your team facing right now?
Thank you, Pooja, for such an amazing session. We do have a few questions lined up. So I'll just present the first one.
I actually answered a couple of them already.
Okay.
And then I have one of them which is open right now. Can I just take that question?
Sure, sure. Yeah, sure.
So one of you had asked that does Disney run red teaming pipelines? Not that I know of. We don't have it. At least on my side of the org, um, red teaming yet. Uh,
Should I move to the next question?
yeah, please.
Okay, sure. Um, okay, yeah. So the first question is, how do you test and cap the token consumption of an agentic testing loop to prevent excess costs during deeper exploratory cycles?
So we are still in evaluatory phases right now. We are still working on getting the agentic um, the whole automation ready, and we are still trying to get an ROI. So I don't have like a number for you yet, but we are looking at consumptions. We are seeing how our regression cycles um, are consuming tokens, how and then probably at the end of the cycle we will have a little bit more idea. But right now we are catching that our is our agent having a continuous loop in an API. So those are the things which we keep on monitoring. Is there an infinite loop going on? Um, is there a like basically what are our bottlenecks can be, and proactively screening through telemetry and making sure that we are not in one of those uh, those scenarios where we regret it later, kind of thing. But yeah, still we are in a exploratory phase right now. We are still trying to see how it will help us out throughout our apps, not just external, right? Not just the consumer facing, but Disney does have a lot of internal apps as well. And we are actively like internal apps, but um, they are like for operations purposes. So we do have a lot of AI work happening there. So we do have a lot of testing, agentic AI testing frameworks which are being tested at the moment. But yeah, it is still we are still keeping in a loop by keeping it on check by seeing that we are not in any of those infinite loop kind of scenarios. So continuously monitoring our logs and making sure uh, we are not there. So yeah.
Okay. Uh, Moving on to the next question. It's when a single user request can trigger multiple AI calls, microservices, databases, and external APIs. Should we start measuring the cost of a business outcome rather than the cost of individual cloud resources?
uh, yes, I think that is true. I think individual cloud resource. I think when we start measuring it as an individual cloud resources, it will be a little bit better for us to gauge how the ROI is, right. So basically, I think that's the way it should be. And even in Disney, when we are looking at the frameworks, we are trying to segregate the cases in those. We do have groups of tests which we run on multiple, we try to segregate them, like API versus databases versus microservices, just to gauge like how we are going to, if we have those segregations in any of the teams, to gauge the whole cost of business and outcomes and everything properly. And because at the end of the day, everyone has to they have to present it to their executives, how this is affecting our business, how it is improving our ROI, kind of thing. So yeah, I think it's a good idea.
Okay. Um, yeah, the next question is, what skills gap hit your team hardest in this shift?
Just the just the gist of it, right? Because we are talking about, yeah, this shift is coming, the quality is not going to be there, quality engineers are not needed anymore. So the just the skill shift, where first of all it's a mindset shift, where you have to constantly remind them that you are still the authoritative person for releases and making the go no go decisions. But yeah, you have to use, like, this is where the future is. You have to use the AI. So skill gap, just to make people uh, you know uh, adapt to different tools we have right now, even like every other company, like Disney has like multiple tools coming. There is something new every week. There are new architectures coming out, so just trying out like what is going on, and then trying to use big, like, as soon as you try to do a POC on one, you get another, something else is new in the market. So yeah, it is a continuous, like, right now it is a gap which keeps on coming back. But yeah, you have to still evaluate, move ahead, not just with the um, people mindset, but yeah, skills too. So it is difficult to keep
Got
on
it.
catching up.
Yeah. We'll take this one last question. And it's, where do humans still clearly beat agents in your testing today?
So see, I have multiple projects with me. So in we do have lot of internal projects as well, where we are not using agents. So it is still, and there is a lot of um, human intervention, yeah, like for a lot of other decisions, right? Just there is a lot of integration test happening. There are, there's a customer user journey which happens throughout the applications which I'm testing. So there you cannot have agents taking the decision of releasing, because there's a lot of risk involved. So humans are still clearly, in my work experience, they are clearly one of the go tos, where they are actually taking no go decisions for the release. Basically they are quality, um, they are guarding the quality for the applications. So I would they are basically the gatekeepers, right? So still, in lot of cases I have seen that, uh, like integration, be it uh, um, just migration. We did a lot of migration work in Disney. So a lot of places where agentic, just having agentic architecture wouldn't suffice, or maybe it wouldn't give us as much as ROI when we are working on it with a human team, or so yeah, I think there are still places where, at least in my org, we are not using agents. There are some clear distinction where we can use it and where we shouldn't be using it. So at this point, I do think that there are places where humans are still important for the testing purposes.
Got it. I think that sums up the session. And honestly speaking, thank you so much for such an amazing, insightful session. And I hope
Thank you.
everybody enjoyed it as well and learned a lot.
I hope that too.
Yeah. And in case, for the viewers, in case anybody missed out on the session or because they had to drop off mid session, you don't have to worry about it. Like I mentioned earlier, all these sessions will be recorded and uploaded to our YouTube channel so you can watch them there. Um, yeah, I think that's it from our side. Thank you so much, everyone.
Thank
Thank
you
you,
so
Pooja.
much. Thank
And
you.
yeah, have a lovely day. Thank you. Bye.
You too. Bye. Bye, everyone.